Hey guys, so we're going to solve a few more problems where we have multiple objects connected to each other. They form a system and we're going to be running through pulleys. The most important thing to remember is that we're going to have one equation for each object we have, and then we're going to put all these equations together. All right, so let's do this one here. Here it says if the table block coefficient of friction, in other words, the coefficient of friction between the table and the block are 0.4 and 0.5, we want to know what is the acceleration of the system and what is the tension on the rope. Okay, so what's the acceleration of this whole thing? It's a system, so it's going to move together. The system could move two ways. It could move this way or this way, and it's always going to be move in the direction that the pulley can spin. The pulley can spin this way or this way. So those are the two possibilities. I have two coefficients of friction here. You should remember that the small one, when you have to, is the kinetic, and the larger one is the static. All right, so we want to write equations, but before we can write our F equals ma equation, we have to know which way this is going to move. And to figure out which way it moves, we're going to look at all the forces on all these blocks along the direction of motion, right? So the direction of motion is this. So for this guy, it's up or down, and for this guy is left or right. So I'm going to look at mg here, and tension here, and then there's a tension here, and because there's friction is going to be this way. Okay, and the way that I can tell that friction is to the left is that if there was no friction, the system would for sure be going this way. So friction would have to be holding the system back by pulling this way. So often the way to figure out the direction of friction is to try to figure out which way things would move without friction. All right, so I have mg, tension, tension, and friction. Now there's two options here. Either the system moves this way or it doesn't move at all. And it wouldn't move at all if the mg was not strong enough to overcome friction. And in this particular problem, you have to check first if it moves. It doesn't tell you that it moves. It could very well be that it doesn't move, and then the acceleration would be 0. To check if it moves, I have to check if mg is greater than the maximum static friction. So let's check that out. Mg is 20, and friction static, which is a maximum friction, is mu static normal. And we're talking about this block here. Friction's on this block, so I have to find normal. There are no forces on the y-axis other than normal and mg, so I can say that normal equals mg. They have to cancel out, and this is a 30. I'm rounding that, using gravity as a 10 to make life a little bit easier here. So mu is 0.5, normal is 30, so friction is 15 newtons. All right, so the maximum friction is 15. That's not the actual friction, just the maximum friction that you would have to overcome to move. And notice that mg is in fact greater than that, okay? So I can say since mg is greater than the static friction or the maximum static friction, we know that the object will move or accelerate. We know that the acceleration will not be 0. The acceleration will not be 0, which means you're going to start moving, and that also means that you're actually going to be going up against kinetic friction. So these are the three conclusions. You're going to move, there is an acceleration, and you're going up against kinetic friction. So this 15 here was just used to make sure that you move, and you do. And because you move, the friction is actually of type kinetic, and friction kinetic is mu kinetic normal. Mu kinetic is 0.4, normal is 30, and this is 12 newtons. Okay, static friction only gets used to make sure to test to see if you're moving, and if you don't move, the acceleration is 0. If you do move, this is the actual friction that you have going up against you, which will always be less, right? So I got 20 on one end and I have 12 on the other end. Okay, so now I could draw free body diagrams for these objects independently and then write equations. I'm just going to write the equations because we don't have to draw the free body diagram. Obviously, if your professor wants you to, then you would. But we can just kind of look at the picture here, and since I'm drawing everything on the picture, see what I'm going to get. We know we have an acceleration. The acceleration has to be this way because this is the greater force. So the system will accelerate this way. So I'm going to say that this is the direction of positive, and this is the direction of positive. Okay, and real quick, look at the forces. mg is going down, and for this object, the direction of positive is down, so mg is positive, but tension is negative. Here, tension is positive because it's going in the direction of positive for that object, right? And then here, negative, okay? Remember what I pointed out last time, that these you're always going to have an even number of tensions. If you have a positive tension somewhere, there's going to be that same tension is going to show up as a negative somewhere else because they're supposed to cancel. So let's now write the equation here. Sum of all forces on the 2 kilogram, I'm going to call this block 2, equals M2A. And sum of all forces on block 3 is M3A. The accelerations are the same, so we just call that A. The forces on block 2 right here are mg going down as a positive, which is a 20. So I'm going to put positive 20, and tension up, so it's a negative there. The mass is 2a. Notice I have two unknowns here, t and a, so I can't do anything, but that's fine because you already know what's going to happen here. You know you're going to need to have two equations, so you're not worried about the fact that you can't solve this right away. Forces in the 3, I have t positive and friction negative. T positive, friction is a 12, so it's plus a negative 12 equals 3a. And if you look here, I'm also missing a t, also missing an a, but it's okay because I have two equations missing the same two variables, and I'm going to do what we always do in these problems, which is combine, add up these two equations to get the answer. Okay, notice how in doing this, we didn't worry about normal or mg because they're not in the direction of motion, right? I only worry about the forces that are going this way and then the forces that are going this way. Cool. Let's combine these two equations here. I have, I'm going to go ahead and put this equation right here. So here's the first one, and I'm going to put the second one here. And it's going to be t minus 12 equals 3a. So notice how the t's cancel. They always will cancel. And this is 20 minus 18. I'm sorry, 12. The answer is going to be 18 equals 5a. So a will be, this is 18, then divide by 5, and 18 divided by 5. I'm sorry, it's 8 divided by 5. Jeez, not 18, it's 8 divided by 5. And the answer is 1.6 meters per second squared. Boom. That's it. All right, and then for part B, tension on the rope, you know how to do this. You just have to plug this number back into either one of the original equations. Okay, so for part B, to find tension, all I have to do is pick any of these equations. I'm going to pick this the second equation right here. Just because tension is already positive, all I got to do is move the 12 over. So t minus 12 equals 3a. So t equals 3. The acceleration is 1.6. And then the 12 comes to the other side as a positive. And if you do this, you get that the tension is 16.8 newtons. Cool. So this question is very similar to what we've done in previously. The only difference is that here we had friction, and we had to actually check to see friction, if the system is moving or not. And once we found out that it was moving, we were going to use kinetic friction. Okay, other than that, it's the same process. Write two equations, put them together, find your A, then find your T. All right, I got a practice problem here. It has no friction, but it is in an inclined plane, and let's try to solve that one.